Well, thank you all for joining. This is kind of a new territory. I've been homeschooling my daughter now for what, a month, going on a month. And I'm excited to learn how to Zoom and do things like this. And I thank you for joining. And I'm going to turn it over to Dr. Somerville, and he's going to give his talk on. Would you go ahead and present your title first, Dr. Somerville? And then I'm going to mute my what Dr. Somerville is speaking. I'm going to mute too.
Sure. The title of the talk is kind of long, but it's the importance of water resources in the Ohio River Basin and how they will be impacted by climate change. So what I hope to do today, number one, is make everybody living in this region feel proud about the water resources that we have. We have a tremendous water resource, although we don't always appreciate it. We kind of think of the Ohio River as being an industrial river, not very pretty, not very, at least in this area, not used a lot for recreation, and we don't think of it as the resource that it really is. So what I want to do is try to impress upon you just how amazing a resource it really is. And then I want to talk a little bit about whether or not we're doing our best job to take care of it. And then in the end, just give you a little bit of information on the latest modeling on what's likely to happen to our flow rates in the Ohio River Basin with projected climate change. So we're not going to talk about weather per se, but we will talk about how the flow in the river is going to change based on projections of climatic change. And I am, let's say, number one, I'll say that this is a new experience for me. I haven't given a lecture online before, so if there are some quirks, please forgive me. And also, I am very much open to conversation, so jump in at any time. Feel free to unmute and jump in. I am not at all disturbed by a conversation. So I'm going to try to share my desktop here so you can see some slides. And let's see. That's the first one. So is everybody seeing a slide now? It's called titled Global Water Crisis, Local Water Opportunities. Is that coming up on,
we do
on
not
your side?
see it, no.
No,
Sorry?
we don't have it.
No? Hmm.
No, I don't have it either.
Okay. So this is that thing. It says share. There's an icon on the desktop that says share. I think that's in my desktop. So
On the far left should say screen.
Far left.
On that share pop-up that came up, you should have a screen option.
Oh, when I hit it, it just try it again. All right, anybody seeing that now? Global water crisis, local water.
It's coming through now.
Okay, very good. All right, sorry. So, like I said, the idea here is to talk about what we have that is missing in the rest of a lot of parts of the world. So we have around the world, water is a very valuable commodity. Around here, we almost think of it as a nuisance. We have so much rain, so much water, so much flow. The river's been flowing pretty high this year frequently, and we think of it more of as sometimes as a nuisance. But in fact, we're in a global water crisis where it's very valuable, and that's one of the points I want to make. So around the world, annually, there are about 1.1 billion people, or about 15% of the global population, that lack access to fresh water. So that you didn't have any access to fresh water near where you live. About 1.1 billion people on the planet experience that every day. About 2.7 billion people, or about 37% of the world population, experience water scarcity at least once per month. And then 2 million people, or about 110% of the West Virginia population, die every year from waterborne illnesses. So when we think about this huge number of people that are impacted by poor water resources, and then the water resources that we have here, we can see that there are opportunities for us to be a player in the global economy just based on our water resources. So if we look at why that's true, and we look at precipitation across the United States, we're in a state where there's 40 to 50 inches of rainfall annually. So there's a lot of rain falling West Virginia on an annual basis. Even surprisingly, if you look up at Washington State, you can see that we're a state that has greater rainfall per year than Washington State. We always think of the Seattle area as being a very very wet area, but we're actually have more rainfall per year than Seattle or Oregon, Washington or Oregon. And then if you look at an elevation map, just averaged across the states, here's Virginia. We are the mean elevation east. So here's the Mississippi River flowing down here, and all the states to the east. We are of the Mississippi River. That's kind of surprising when you look up here in the. You think of the White Mountains and all of that. We're actually at a higher elevation than those areas. So what that means is when water falls, a lot of water falls per year in our area, and when it falls here, it runs off in all directions. So our northwest border, southern border of Ohio, southern border of Indiana and Illinois, where it joins up with the Mississippi River. Into the Chesapeake Bay. The north of the state up to Pittsburgh, and then flows southwest from there. So we are really the mother of rivers for the eastern United States, and we have this tremendous water resource that we share with the rest of the United States. Now this may look at first like it's a map. It's kind of an engineering chart of flood flow pathways in the lower Ohio River. So here's the Ohio River up to the upper right of this diagram, and you can see that coming into this area, we've got the capacity to handle 1.76 per second, million cubic feet per second. It's a lot of water, and by comparison, here's where the Tennessee River comes in, and so where the Ohio River meets up with the Mississippi River, we have the capacity to carry 2.25 million cubic feet per second of water. By comparison, we all think of the Ohio River the Mississippi River as just a huge major river in the United States. So here's the Ohio coming in, here's the Mississippi above the Ohio. So the Mississippi River above the Ohio River has the capacity to carry about 150,000 cubic feet per second. That's still a lot, but it is dwarfed by the Ohio River when it comes in here. So when we think of the Mississippi as being the mighty Miss, this amazing river in the United States, it truly is that, but it really is that because it collects all the water coming out of the Ohio River. So this tells us that the Ohio River Basin is really and truly the major water resource for the eastern United States. And if we were naming rivers now by the convention that is currently used, so if the Ohio River, Mississippi River were named according to modern conventions, this would be the Allegheny River. All the way to the Gulf of Mexico would be called the Allegheny River, because the major tributary at Pittsburgh, where the Ohio River is formed, is the Allegheny River. Then that river flows down into Mississippi, and the Mississippi is by far the smaller river at the confluence. So the river, by all rights, actually should be called the Allegheny. So the bottom line of this little portion of the talk is that the Ohio River Valley is a source of tremendous water resources in a very thirsty world. So where water is needed around the world, we have a huge amount of water. It's both a responsibility for us and it's an opportunity for us. That because of that, we want to ask ourselves some questions. Are we doing a good job of preserving and protecting this valuable resource? And then how are we going to manage this resource with changing climate? How is it going to be impacted by changing climate, and what do we do in order to manage? So I'm going to address this first question first. Are we doing a good job of preserving and protecting this valuable resource? So I'm going to flip over to another brief set of slides, and hopefully this will come up on your screen as well. All right, is everybody seeing one called America's Watershed Initiative,
Yep.
Raising the Grade? Very good.
Yep.
Before I jump into that, any questions so far? Any comments? All right. This next presentation is based on a report card that we published. I was part of the America's Watershed Initiative Board of Directors and was a member of the report card working team. We published this report card back in 2015, and we are preparing very shortly to publish the 2020 version. So I'm showing you the 2015 version because the 2020 version is not quite completed yet, but we will be coming out with another grade for the Ohio River and for the Mississippi River as a whole. So this group, America's Watershed Initiative, works across the entire Mississippi River Basin, and I was a member of the team that represented the Ohio River Basin. So if we look at this stylized map of the Mississippi River drainage, we've got this huge expansive area up here in the northwest of the Mississippi River Basin. Mid River Basin, Lower Miss. We've got the Tennessee River Basin. It's technically part of the Ohio River Basin because it does connect to the Ohio River before it joins the Mississippi. But a lot of political and governmental boundaries, we treat the Tennessee River as a separate watershed. And then we've got the Ohio River Basin up here, which is our home and, again, the major source of water for this entire system. So what we did is we looked at these at all of those river basins, and we asked ourselves, how are we doing in terms of these 6 metrics? Rivers, clean, abundant water. Are we, as managers of these rivers, protecting people against flood? So how's our flood control and risk reduction? What are the economies like in these basins? Do we have healthy economies? Are they struggling? We graded recreation. How are these rivers providing recreation for people living in the area? What's the status of the ecosystems in these river basins? And because transportation is such a valuable, we actually put a separate grade on the transportation industry. So those were the 6 areas: clean, abundant water, flood control and risk reduction, economy, recreation, ecosystem health, and transportation status. Those were the grades. And so now that we did that across the entire Mississippi River Basin, what I'm going to show you now are the indicators that we use to put a grade on those areas. And then for the Ohio River Basin, these indicators are indicated by color what the grade was for that area. So under water supply, we looked at water depletion, we looked at how much water is coming into the basin, how much is going out. Put a grade on that. For the Ohio River Basin, that grade was a B. Then we look at treatment violations. What percentage of the population in the area served by supply systems without treatment violations? And we still, even though we've made a lot of progress in this area, we still earned a D in the Ohio River Basin for the percentage of the population that does experience water supply violations. So water supplies contaminants. And then we got it in the treatment of that water for use. In flood control indicators, floodplain population change was one of our metrics. So we looked at population in the 500-year floodplain. We looked at the status, the engineering status of the levees in the region, and then we looked at the percentage of the population that lives in communities with mandated elevation requirements. So really what we're trying to do there is we say that if we're managing for flood control well, then we're going to keep populations out of risk areas. And so that's one of the metrics. Then how are we doing in terms of levee condition? How are we doing in terms of population change? People in the floodplain versus people out of the floodplain. And we got a C in each of those categories. So the grade for each of those in flood protection was a C. Not great, but not terrible. For economic indicators, this region we scored a B for river dependent employment, number of jobs in the river sectors. And 2013 was the most recent data we had. Back in 2015. Median income for this area for us was actually relatively low. That shouldn't surprise anybody in the Appalachian region that median per capita income was relatively low. And then gross domestic product by sector for selected industries in 2013 and in our region was a C for this economic indicators. Recreation, we did not do well in recreation, outdoor participation, hunting and fishing licenses. We scored a D and an F in those categories. Yeah, I'll just say that this was a tough one to get a handle on. This was the first report card for the entire Mississippi River Basin. It was a pretty big check metrics on all these things, and it was difficult to get a good handle on really how to measure recreation. So that's one of the areas that we're trying to do differently with the 2020 report card. But what we did look at did not indicate that we were effectively using this resource as a recreation economic driver. And then for ecosystem indicators, we had water quality. This is total nitrogen and phosphorus. If you're following kind of what happens in the Gulf of Mexico hypoxic zone, a lot of that is driven by nutrients coming off of where people live, on farmland, cities. A lot of nitrogen and phosphorus come off those areas. It causes algae to grow in the river. When the algae die and they're being broken down, then oxygen is consumed, and that's what drives those large hypoxic zones lower in the system and out into the Gulf of Mexico. So nitrogen and phosphorus is a kind of a proxy measure for contaminants that are going to end up causing problems. Communities. These data, excuse me, came out of the EPA National Rivers and Streams. So those data were from back in 2008, 2009. That's an assessment that only happens also from the river and streams assessment. That was a C, wetland area change. we actually saw some improvement in wetland areas in the basin. And so that was a grade of B. So we had a D on water quality, a D on living resources, a C on streamside habitats, and a B on wetland area change. And then the transportation indicators, the big issue here is that a lot of the infrastructure that allows us to have marine transportation on the rivers is maintained by the Corps of Engineers. A lot of that infrastructure on the Ohio River is way beyond its design life. So we have locks and dams in the upper Ohio River that are approaching 100 years in age. They're designed for 50 years. If you've ever walked through some of those structures, they're a little bit scary. And it's because they really should be replaced. So we graded infrastructure condition for the basin, for the Ohio River Basin. That was a D. Infrastructure maintenance, this was really a comparison of the operation and maintenance funding provided to the Corps of Engineers versus the budgeted need or the requested need to maintain the navigation infrastructure appropriately. There was much less funding provided than asked for, so that was an F. And then lock delays actually did pretty good. So we didn't see a lot of cargo being held up at locks on the Ohio, but it's really not a good reflection of the condition of the infrastructure or the ability to maintain it. So the bottom line really in this area is the Corps of Engineers is doing a very good job at keeping those locks open and running, even though they're very old and the maintenance budgets are way below where they need to be. So this is a little bit busy, but I'm sorry?
Is the lock situation positively affected by the reduction in coal shipping? There's so many fewer barges out now. There's nothing to hold up a lock, really.
Right. Yeah, that's a great question, because the lock delays are going to be even better in terms of there are going to be fewer delays because of the reduced traffic. But even though a lot of the infrastructure funding comes from the federal government, the shippers pay a tax on the tow of diesel. I think there's something like I'm probably going to get the number wrong, but it's taxes that goes into the maintenance of the infrastructure. So it's conversely, as the shipping, there's less demand on the use of less wear and tear. There's also less or pot to help maintain them. So it's kind of a non-virtuous cycle. As shipping goes down, maintenance goes down as well.
Thank you.
Addressing your question?
Yes, thank you.
Sure. So this is just kind of the overall report card. If you look at the Ohio River, these are the other basins in the Mississippi River Basin. Just look across the Ohio to look at the grades. So recreation was a D, ecosystems was a C overall, economy is D overall, transportation and flood risk reduction, D's overall, water supply was a C. So again, we have a huge water supply. We have a wonderful, abundant water in our area, but we have problems with keeping that water clean for its best uses, and so that's why this grade is low. And so overall, the grade for the basin in 2015 was a C minus, which was a little bit better than the grade for the Mississippi River overall, which was a D plus. But to answer the question, are we doing a good job of taking care of this tremendous resource that we have? I think the answer is we can do better. the 2020 version of the report card will have an update on this. I've seen some of the data for that, and it looks like we may see a little bit of improvement there, but we still have some ways to. All right, just some of the folks who were involved in that study: Heath Kelsey, Bill Dennison, Bill Nuttall, Jane Thomas. All these folks were from University of Maryland Center for Environmental Science. The report, and then the folks who were involved from America's Watershed Initiative are listed over here on the right. Jordy George, all the time that study, was the executive director. All right, any questions about that that little part of it? Again, that's an attempt to address the question of whether or not we're taking care of the resources that we have. And I think the bottom line there is that could do better. Sorry. This last piece is about climate change, and this is another study that came out of this. So the engagement that I had with America's Watershed Initiative was because of my involvement with a group called the Ohio River Basin Alliance. So the Ohio River Basin Alliance was stood up in essence or backed by the Corps of Engineers, the US EPA, and ORSENCO, which is the Ohio River Valley Water Sanitation Commission, because those groups felt like they needed a unified voice to go to not only to Congress but to the public in general, and to talk about the value of the water resources in the Ohio River Basin, and to talk about the fact that we need to manage them better, and we need investment, both state level and federal level investment in managing these resources in a unified. So when West Virginia manages its water, that has an impact on the Ohio River, but how we manage our water is different than the way Ohio manages their water, or Pennsylvania manages their water, or Kentucky or Indiana. So ORBA is all about trying to get states to work together so that they're managing in a way that that benefits this the Ohio River and the waters in the Ohio River Basin in a coordinated fashion. One of the things that the Ohio River Basin Alliance did was to work with Institute for Water Resources in Alexandria, Virginia, to look at a scaled down climate change model for this basin, to try and understand how flow in our rivers is going to change over the next several decades, driven by climate change. Excuse me. And that is, a lot of that is driven by the Corps of Engineers, because the Corps of Engineers has a vested interest in managing waters of the United States. They have to maintain the not only the flood control structures, they have to maintain the water supply structures, they maintain the navigation structures, and so they're very much interested in knowing how water flow is going to change over the years. So the Corps of Engineers was very much involved, National Oceanic and Atmospheric Agency, EPA, the Geological Survey, the University of New Hampshire, University of Cincinnati, Marshall, Nature Conservancy, and Battelle were all people who are organizations who participated in this study. Excuse me. I don't know if any of you knew Dr. Jeff Kovach. Jeff was an associate professor here in the College of Science, and he was the main participant from Marshall on this study. Unfortunately passed away back in 2016. He was a very young man, 39 years old. Had a brain aneurysm. Came to class one day and just slumped down in the hallway, and just a little bit about a month after that, passed away from a brain aneurysm. So very sad loss. Jeff was a great guy, and I want to just make sure to point out that this was a large. What I'm going to tell you about now came from his work. So what this team did was they looked at climate models from the International Panel on Climate Change, the National Weather Service, the Corps of Engineers, and the partner states and universities. Excuse me. And then they scaled those models down specifically to this area of the country. So it's easy to look at these large scale climate models. What you want to do is know your local impacts. So they took a large amount of flow data from the U.S. Geological Survey and the USC, and they worked with these models to try and predict what was going to happen in this area over the next several decades. So the team picked 25 locations in the Ohio River Basin, and they modeled 4 different data sets. They had 3 forward-looking data sets, F1, F2, and F3. And so the F1 data set models the flow in between 2011 and 2040. So we are already in the F1 data set. The F2 data set models the flow from 2041 to 2070. F3 data set models the flow from 2071 to the end of the century, 2099. And then there's a reverse looking data set that looks at flow from 1952 to 2001. And basically what that one is for is we would together the model, run the model, and then ask whether or not the model accurately lines up with data that we could go back into the archives and look up. So the R1 data set is basically a test to see how well the model is performing. Excuse me. And if we look back at the historical data, the actual historical data and the model data, we can see that there's pretty good agreement between the max and the min flow rates. There's very good agreement at the mean level. So the average flow at all the 25 sites across the basin, back in the historical models, the mean flow was always within 2% of the measured flow. So the model was doing a good job at the average level for predicting or modeling what had passed, and we could actually verify the reverse data set based on historical data. Again, there's really good agreement between the modeled mean flow and the historical mean flow. Pretty good agreement between the minimum flows and the maximum flows in Cincinnati. Golconda, which is southwest of Cincinnati, on the actually southwest of Louisville on the river. Again, really good agreement at the mean level. A little bit of difference between the minimum flow prediction and the minimum flow historical. Pretty good agreement at the maximum flows. So just as a comparison, this 185,000 cubic feet per second at Golconda as a mean historical flow. That's about 1.4 million US gallons per second of flow. So that gives you some idea of the flow of the river down at Golconda. Here in Huntington, on an average day, the mean flow is right around 1 million gallons per second. So if you stood at Harris Riverfront Park and look across to Ohio and just draw a line across there, and imagine that on an average day, about 1 million gallons are passing under that line every second. That gives you a feel for the volume of water. And right now we're flowing at a good bit above our mean flow, so we're probably in the 1.5 to 2 million gallons a second range at the moment. So what I'm going to show you in the next 3 slide is the minimum flow, the mean flow, and the maximum flow predicted in the Ohio River Basin in the particular time frame. So this is the F1 data set, 2011 to 2040. This is the data set that we're already, and the colors are yellow color is lower flow than historical data. The gray color is approximately what you'd expect from historical flow. The green color is 5 to 15% higher than historical flow, and the blue color is 15 to 25% higher than historical flow. So the model says that within this time frame, we are going to see on average our minimum, our low flow period. So the times of the year, usually that's in late summer, when we have our lowest flows, that our lowest flows will be in southern West Virginia will be 20 up to 25% higher than our historic low flows. For good parts of the northern part of the basin, flows won't change that much. But in our area, and a good deal of the eastern part of the basin, we're seeing 5 to 15% higher in an interpretation of that graph or that map, and we'll use the same color schemes for the other one. So our mean flow, our average, and that's the one that the model really does a pretty good job of predicting. Our mean flow showing us that southern West Virginia is looking at 15 to 25% greater mean flow in the entire eastern part and southern part of the basin, all the way down to the Mississippi River confluence, as far as the Tennessee River. But the whole southern part of the basin is going to see 5 to 15% more average flow. So what that means for us, I'm sure that you all know, we see a lot of people experience flooding in the southern part of the state. And that means that flooding is going to be more common and more of a problem to manage than it has been in the past. When we look at our high flows, the model is even a little bit more scary. The entire eastern, the entire state of West Virginia, which is largely in the Ohio Basin, we just missed this little part of the eastern panhandle. Just about the entire state of West Virginia is going to see 15 to 25% greater stream flow within the period that we're already in. So this is not a really much of a future prediction. This is things that are happening now. These high flows that we're seeing are predicted by the model. When we move to the next, the 2 model, the 2041 to 2070 model, you can see that there's some reduction in flow. At our minimum flow, we're going to see lower flow in western Ohio. This looks like Miami River Basin. In our area, our low flows are going to be 5 to 15% higher by prediction of the model. Our mean flows, again, are similar to the 2011, 2040 database. We're looking at 5 to 15% increased flow here. But then in this time frame, this F2 model time frame, we're looking up 25 to 35% increase in flow in southern West Virginia. So at our maximum flows, we're going to be 25 to 35% above our historic norms for this area. So again, that is pretty scary. And for the basin as a whole, we're looking at anywhere between 5 and 25% changes in flow to the positive side. When we get into the F3 database, it starts to become apparent where the long-term trends are for us. And the long-term trends are saying that much of the basin at low flow periods of the year is going to be lower than it has been historically. This part in central Ohio, this might be the Scioto River, I'm not certain. This as much as 25% less flow in that area than historic. The entire northern part of the basin is going to be between -5 and -15%, so up to 15% lower flow than historic lows. And we're still going to be a little bit higher in southern West Virginia, but large parts of the basin are going to be drier than they have been in the past. And I'll come back to that in a second. Mean flows are going to be increased. We're in 15 to 25% increase in much of West Virginia, with a little bit of southern West Virginia being up to 25% higher in the mean. And then when you look at these maximum flows, this is where it really becomes kind of scary, is that in southwestern West Virginia, we're looking at up to 50% increases in our maximum flow over our historic. So we've already seen in the history of West Virginia, we've seen lots of floods in southern West Virginia. We're going to see up to, by the model, we're going to see up to 50% higher flows at maximum flow in parts of that parts of our state and in the eastern Kentucky. And in the entire eastern part, so this is the Allegheny River drainage. Here's the Monongahela River drainage coming up this way. We're up to 35% increased flow throughout the entire state. So what this long-term model is telling us is that our lows are going to be lower than they have been in the past, and our highs are going to be higher. So we're moving into a stage now where, or we will be moving into a stage where we have episodic drought and episodic flood. And so the picture overall, and a lot of times what you'll hear from people talking about climate change is that this part of the United States is going to get more rainfall. We're going to have more water resources. And that is true. Overall, we're going to see more flow in our rivers. But there are going to be times where we're seeing drought, where the river flow is going to drop below where it has been historically, which is going to put a huge impact on shipping in the basin, a huge impact on electric power generation, a huge impact on water supply for cities that draw water from the Ohio River and from their local rivers. And so we really have on our hands in the future, very big management issue with trying to level out the episodic lows and highs. And so that's kind of the picture, long-term picture, is that we have to become better. The challenge for us is to become better at managing these episodic highs and lows. So just to kind of summarize where we've been so far on the climate change study, we're in the F1 period now. We're about halfway through the F1 period. We're already seeing that increasing flow, particularly in southern West Virginia. We're seeing floods above where we normally above the occurrence rate we normally see them, and that is something that we've got to do better managing. When we get beyond 2040, our minimum flows become lower and our maximum flows become higher, and again, that poses for us a big management problem. It's not too early. Sadly, when I saw this data presented in a Corps of Engineers meeting about 2 years ago, the takeaway was, we still have some time to think about this. My hair is on fire, much more so than that. I don't think we have a lot of time to think about this. I think we have to be, as a society, working on how we're going to manage these issues now, because we all know from the infrastructure, from the transportation infrastructure up around Pittsburgh that was built back in the 20s and 30s, that it takes a long time for us, once we start to think about changing our management, to get to the point where we actually do change it. And so it's not too early to make those plans and to start thinking about, to be not only thinking about it, but moving on what we're going to do to manage this change. So you have influence here. You have you vote. You contact your Congress people and senators, and you can tell them that you're proud of your water resources, that you understand how valuable they are to the United States and to the world in general, but you also need an investment in these water resources in order to manage them properly, to get water quality that you deserve, to get the ecosystem services that you deserve, to get the kind of transportation system you deserve, and to protect you from the episodic increases and decreases in flow that we're likely to see over the next several decades. And that brings me to a couple of pictures from the Herald Dispatch showing pretty high flow back here in 2018 when the river was well up, and for the first time in a good while, we actually put up the floodgates at Harris Riverfront Park. So just another little reminder that we are in an area or in a period of time when this type of flooding is not going to be unusual at all. We're going to see more of it. All right, I will get out of this and ask if you've got any questions. Okay. I think I heard somebody say they didn't have any, but I may
Are
not
we
be
still
hearing
on?
everybody well.
Yes.
You're
Yes.
hearing me? Okay. Good. Any or comments? Doesn't have to be questions for me. There's a lot of experience on the phone or on the meeting. I'd love to hear thoughts and ideas.
Am I being heard?
Yes, I can hear you.
Okay, I just wanted to thank you for a really informative program. Some scary information.
Who would be? Is someone listening by phone?
We're
Sorry,
looking
I'm sorry.
and listening by.
See, they have
Go ahead.
Okay. Are you hearing me now?
Yes. Yes.
A little bit.
Okay.
I turned my volume up. Go ahead.
Okay. We need a little help with the technology.
You and me
Just
both.
wanted to thank you for a very informative talk. And particularly some of the information is kind of scary, but very valuable, especially about the flooding and the condition of the locks and dams. So thank you. And thank you for doing this in this very new fashion.
I think
I'm sorry, I missed part of it, but
she just saying this
I'm
for
sorry, it's scary.
she says kind of scary with the flooding and such, and she just thanking Dr. Somerville for participating in this manner. I just hope that people that wanted to get on could get on. If anyone has any questions, we have some time.
So are there plans now to replace one or more of the locks on the Ohio River?
There's a brand new lock down around Paducah, Kentucky, called Olmsted Lock, and that's been in the works. Now, some of you may know more about the completion of Olmsted than I do. That replaced two old that were built in the 20s. So that infrastructure is nearly complete now, and that's a very good thing for navigation in the lower part of the river. There are significant issues with the infrastructure up around Pittsburgh, and I do not know of any plans presently for the replacement of those. Their lock walls are crumbling. Sorry. I'm sorry, I think I may have lost you.
How about the condition of the Robert Byrd locks?
The Bird Lock and Dam locks and dam are in pretty good. I want to say in the 90s, I believe. more recent areas. Of delays at the Birdlocking Dam.
Thank you.
Certainly. If you've ever visited there, it's actually pretty cool. And I don't know if you have to arrange with the Corps in advance to watch a boat lock through. I don't think you have to. Although safety concerns with getting too close to the lock walls, but I'd recommend going up and watching some of the commercial vessels lock through. It's pretty impressive if you haven't seen it.
Well, we visited the bird locks, but we haven't seen any vessels locked through. On the other hand, several years ago, we took the Delta Queen in the lower part of the Ohio and went through several locks. And know what they feel like.
Do you remember locking through the 52 and 53, which were the old wicket dams at the lower part of the river, or maybe the water was up, and those were relatively low head dams, so in high you could actually sail right over top of the dam structure. You only had a.
I
So
don't
do
think
you remember going through those?
We began the trip at Nashville and came through.
Okay.
So we came in further up the river.
You may have come up the Tennessee then. You probably came up the Tennessee Tom Bigby Waterway and up the Tennessee River. Yeah.
Yes.
That's beautiful down there. I love the lower Ohio. It's just a beautiful river.
It is.
Dr. Somerville, this is Bill Wilson. Your striking statement about the management issues of our episodic highs and lows, and then your encouragement about actually communicating and with people in our federal government, in our state government about that management. Is that, if I understood you right, it's the advocacy needs to be to encourage our officials to be concerned about flood control, about ecosystems. Are those the primary, and the infrastructures, I assume, when they're coming in the flood control? Is that kind of what you were suggesting?
Yes, sir. I would say that. And the interesting thing for me is this is a totally nonpartisan issue. This is I think that people from all political sides can get on board on this, because I kind of consider myself to be a tree hugger, and I care about the status of the ecosystem. But these groups that are working on these big rivers, the America's Watershed Initiative and the Ohio River Basin Alliance, they are not partisan, and they are as very much interested in economic development as they are in ecosystem services. And the nice thing is, we sit as a committed or admitted tree hugger. I sit down with folks from the transportation industry, and we're on the same page. We're talking about we've got to manage this system so that it not only optimizes transportation, but we can do the transportation in a way that protects the fish and the mussels and the native plants. We're convinced it can be managed in a way that allows all those things to coexist. And so that would be my message, is that we're not lobbying for transportation. We're not lobbying for the environment. We're lobbying for the whole picture.
Mm-hmm. Mm-hmm. Thank you.
Yeah.
Do we have any other questions? Any comments? Dr. Mofson, do you have anything else?
Nothing else.
I want to thank you all for allowing me to kind of experiment on you, because I haven't done this type of talk before, but you can tell I love this river. And I believe in its I believe in its power. I believe in its impact on this region, and so I'm always happy to talk about it.
I think it went quite well today. I got it. And thank you, Dr. Somerville. It was very, very informative. I got a couple emails. We do have people participating via their smartphone. I've sent an email out to see if people couldn't get on. And so if we have some kinks to work out, we can work them out for the next one. But this will be on the YouTube channel. Eric Himes, our moderator, Eric, is recording this. And so for those who couldn't get on or weren't available, what have you, it will be able to be viewed again, because I think it's something that people are going to want to go back and listen to that couldn't participate. So is there anything else that we need to talk about?
Just thank you, Elizabeth, for arranging it
Oh,
and getting
done.
this new process going. We'll have a few kinks to work out on our end, and I'm sure others are going to probably do the same.
Right,
and
and
it was a good start.
Well, thank you, Diane. And I do welcome any kind of feedback. And I do thank Dr. Somerville, because, you know, this all got pitched at us so quickly, having to leave the premises. Dr. Somerville, I think, is able to be at work. He's more of an essential employee. And I just thank him for doing this for us. I think it was quite, you know, huge for him to step up and say, I'm going to do this by Zoom and we're going to see how it works. And I think it worked quite well. I just hope that people that couldn't get on won't be too disappointed, because again, we'll welcome feedback and see what we can do for our next talk. So thank you so much, Dr. Somerville. I really, really appreciate it.
Oh, you're most welcome. Thank you. Thanks very much for hosting.
Well, you're welcome. Such a great talk. We do these bonus Tuesday talks, and maybe when we can meet again in person, we'll have you come in person. I think we have a lot of people who would be interested in have some dialogue back and forth about it. So we can maybe reserve that for the future if you don't mind. I put you on the spot, I realize.
Yeah, love to. Thank you.
All right. Thank you. Thank you, everyone, for participating. And please email me with any thoughts or comments. I would look forward to it.
Stay well.
Yes, thank you. Stay well.
Stay safe.
Right.
Thank you.
Bye.
Most
Have
welcome.
a great day.
Bye.